Hi, hi everyone. So today I'm gonna discuss one of the favorite topics, or let's say one of the most debated or more discussed topics in C++, and that is the use of const variables and the use of constant expression variables, which is like const expr. We put it in front of a variable definition. um in the program. So we're going to discuss these two things in this brief video, and I'm going to uh, try to explain you the basic difference between these two and why these two are introduced in the language. So, and these two are very useful keywords to be used in front of any variable. It defines the behavior of that variable in the program. It reduces variance in the program. It gives the author, the coder, the programmer more control of the variables. So these are very useful techniques when you have a multi-program um, sorry multi-project programs. So in multi-project programs, you may be having some of the variables floating across each and every functions and projects. So in those cases, we need to be careful that we handle these variables properly. So let me start with what the const keyword means. So let's say if you have defined const int a equal to, let's say, 5, which means that the variable a is a const in this case. And then you may ask me, like, what const? Like, is it runtime cost or const, or is it a compile time const? And that is where the difference comes in. So the const keyword only assures us a runtime constancy of that variable, which means when I'm initializing the variable, let's say, for example, in this case, let me tell you that there's a variable called int b equal to 3, and then we have const int a initializing b. So now you would say that, hey, wait on a minute, but int b is non-const, but then you are initializing it into a const variable. So how does this work? So basically that is exactly what the const word handles. It handles the runtime evaluation. So once it is initialized with with the value, it makes sure that during the runtime, it is constant, but it doesn't guarantees that we will for sure know the value at the compile time. So when the compiler is running, the compiler still don't know what the value of b is going to be if it is coming from some other program. And that is where const expression comes in. So const expression is one level higher to const. It it says that, hey, I'm here to make you give the authority to make your variable constants at the compile time. So that is a basic difference between these two paradigms, these two keywords in C++. So const expression is like the compile time constant. It ensures that at the compile time the variable is constant. So the compilers can evaluate the expression and reduce the value of that variable at the compile time, and it makes sure that it is the same value throughout your program. Whereas in case of const, the value can be a non-const value, and it could be it could be evaluated at compile time or at runtime. So that is the case when we use const variable. Now, that is aside. Now we'll see what the use cases are like. Um, so the function parameters, like for example, in some of the function we have the parameters, and those parameters can never be const expression, because you never know what the value is going to come. You're going to only know when the runtime, when at the program is running, and the runtime, what variable is going to come in the function and what is going to fall through. So that is why in the function parameter we always have the const keywords used. And another use case is, like for example, not every data type supports const expression. For example, there are special data types which gets dynamically allocated during the runtime. For example, the very famous std vector. And yeah, std string as well. It can also get dynamically large. So these variables have can only be declared const. They can't be declared const expression because you don't know the size of the container, what it's going to be and how much big it's going to be. So the other side of the world, which is the std array, int, double, float, these variables can be made const expression because we know the exact size of it. Even in array, we have to define the size of the array which we're going to use. So that is where const expression comes in the picture. And performance wise, both give a good amount of performance, but const expression is 100% much more performant than const. So yeah, I hope it made sense. I hope you learned something new. I hope I added some value to your knowledge. Thank you very much. Cheers. Bye bye.